Hello everyone, my name is Nehal. Welcome to my YouTube channel Backend Logic Made Easy. From this video, we will learn array data structure. Today we are going to cover all these 4 points in detail. First, what is an array? Second, example of an array. In earlier previous video, we already discussed how to access an array, how to define an array, and how to traverse an array. Third, how memory allocation of an array is continuous. And last one, why does the array index always start from 0, not from 1? First, let us understand what is an array. An array is a collection of similar types of data items stored at continuous memory location. That means, if we create an integer array, we can store only integers values in it. An array is a simplest data structure and we can access element by using its index number. Let us see some simple example. Here we declare an array integer AR of 5 is equals to the 10, 20, 30, 40, 50. At 0th position of ARR, we store 10th value. At first position of ARR, we store 20. At second position of ARR, we store 30. At third position of ARR, we store 40. And fourth position of ARR, we stored 50 values. Here 0, 1, 2, 3, 4 are nothing but index of an array. Each element is identified by its index number. Now see how memory is allocated an array continuously. Assume that base base address of an array is 100. First, let us imagine this picture. What does this picture mean? This is the index of 0, 1, 2, 3, 4 are the index positions and the corresponding these are values stored at that index position 10, 20, 30, 40, 50. Now we calculate how address will be stored at continuous. First, we know that size of integer is 4 byte and here our array is an integer type. Array type is an integer array. So here we assume the base address is 100. So we are increasing the base address by 4 bytes. Therefore, item stored at AR of 1 is address will be 104. At second index position of item stored at 30 of address will be 108 and so on 112 and 160. That's how the elements are stored in a continuous memory location. Why does the index start from 0? Many beginners think this is a confusing, but once you understand the logic behind, it becomes very simple. An array index does not represent a position. It represents offset from the static memory address. Let us see some simple example. Example. Here is our integer array 10, 20, 30, 40, 50. We know that each integer takes 4 bytes of memory. Now assume the base address is also starting from 100. See this picture. The first element is stored at 100 address. So its index is 0. Actually, the computer uses To calculate the address of index position, this formula address is equals to the base address plus index into size of data types. Here, to calculate the base address, which is we assume here 100, at index position 0, we put here base as address is equal to the 100, index is equal to 0, size of data type is equal to 4. Therefore, 100 plus 0 into 4, that is equals to the 100. Therefore, address is equals to the 100. This is directly gives the correct address for index 0 if we put in the formula. Now, why not start from 1? If the index started from 1 in this formula, if we put the base address is equals to the 100, index will be 1, size of integer will be 4, 1 into 4 is equals to 4, 4 plus 100 is equal to 104, and the address will be 104. The first element will be skipped, so the computer will need extra calculation every time to get correct index position, correct base address. So starting from 0 make access faster access, get simpler calculation and more efficient to handle. And why not index from 1 is therefore the first element will be skipped. We need extra calculation to get correct base address or correct address of index position and less efficient. That's why the array index starts from always 0 because index represents the distance from the starting address and the distance of the first element is 0. So today we learn what is an array, example of an array, memory representation, why index starts from 0. In the next video, we will learn about 2D array, rows and columns, and address calculation in 2D array. Bye guys. See you in next video. Thank you so much.